The Sky Method. Chapter 3, Parts 2. Technical description of the Sky Method. This is an explanation of a money-saving wastewater treatment method being developed by the Green Ninja Group in the Philippines. What I want everyone to understand. The Sky Method is an idea for a water treatment method that does not require expensive aeration power and large amounts of steel and concrete. I am looking for someone to do some additional experiments with the Sky Method. Please pay attention to this point in your reproduction experiments. Please watch the Sky Method Chapter 1, Chapter 2, Chapter 3 Parts 1 and 3 video if you haven't seen it yet. Its web address is in the description field. Look at the records of small-scale experiments. The background is the basic flow diagram description of technology of the Sky Method. This is the Sky Method as illustrated in the schematic diagram. This is the structure of a practical scale experimental facility that treats 10 cubic meters of wastewater per day. See the description field for the web addresses of these enlarged diagrams. Please look at the drawings on a large display, not on a portable device. Features of the Sky Method. 1. Protect the natural environment without compromising humanity. 2. The components are stacked vertically to save floor space and to utilize the gravity drop of water. 3. Gives a positive charge to the wastewater. 4. The sponge containing the wastewater is exposed to natural wind to provide oxygen to aerobic microorganisms. 5. Effective use of oxygen produced by the photosynthetic action of plants. 6. The use of natural products such as pumice and coconut fiber. 7. High circulation rate of treated water. Sludge is also circulated, and the treated water is fed back to the previous stage. This is a structural drawing of a practical scale experimental facility that treats 10 cubic meters of wastewater per day. Facility dimensions. Depth 2.5 meters. Horizontal 2.5 meters. Height 3.5 meters. Target power consumption, less than 1 kilowatt-hour. Daily process capacity, 10 cubic meters. Features of the Sky Method. These components are stacked vertically. The reason for this is to reduce the floor space and to utilize the gravity drop of water. The structure in the illustration is made of construction scaffolding because it is for experimental use. This is a picture of the tank and sponge of practical scale experimental during preparation work. This video shows a sponge being sprayed with water as a test. I will now explain how the Sky Method works using schematic and structural drawings. The process consists of 11 sections. Section 1. Dirty water collects in the sewage and drainage channels. Section 2. Use the feed pump, Pu1, to pump up dirty water to the additive mixing tank, TK1. The water level in TK1 is controlled by the float switch, FL1. Cover the pump with coconut fiber. This is an intake filter with no solid waste in the pump. Effective microorganisms live in this coconut fiber and help purify sewage. Features of the Sky Method. It is to supply a positive charge to the wastewater. Section 3. Place the additive with positive electric charge into the tank, TK2. Add the additive to the additive mixing tank, TK1, through the valves, VL1 and VL2. Note, the developers are aware that this method does not allow for meter dosing. We already have a rough draft of a dosing method that does not use an electric pump. We use alum, a natural product in the small-scale experiment. Dirt in the water has a negative charge. This causes the dirt to repel each other and wobble around in the water. Therefore, it cancels out the negative electricity of the dirt when positive electricity is offered. This causes the dirt flocculants will form in the water. Look at the record of a simple flocculation experiment using alum. We will get dirt flocculants. It seems that microorganisms are more likely to eat dirt flocculants. This is an assumption based on experimental results. However, it has been confirmed in experiments that when positive electricity is supplied, the microorganisms eat the dirt quickly and the water becomes clean immediately. There are other ways to provide a positive charge. Electrolysis of wastewater creates dirt flocculants. The developers have not yet conducted this experiment. Here is an actual example of electrolysis. I assume that electrolysis strong enough to precipitate flocculants is not necessary in the case of the sky method. This is because the purpose of electrolysis in the sky method is to facilitate the formation of microflora. It is not necessary to separate the flocculants. Flocculants, electrolysis, and microbial treatment are all useful. However, good wastewater treatment cannot be achieved with only one method. The best parts of various methods should be used together. The water to which the additive with positive electricity has been added is pumped by secondary feed pump, Pu2, to the dripping water tank, TK3. Section 4. The water in the dripping water tank will drip onto the sponge. Section 5. The hanging sponge is filled with water. Oxygen is supplied to the microorganisms living in the sponge when the sponge is exposed to natural wind. The water must drip down and come into contact with the air after being contained by the sponge. The dimensions of the sponge are 25 mm, 1 inch, width-wise and 50 mm, 2 inches, length-wise. The sponges are attached alternately to the retaining net. These dimensions and mounting methods were determined after several experiments. Oxygen-loving microorganisms live in the sponge. These microorganisms eat the dirt in the water and reproduce. This is why the water becomes clean. The main feature of the sky method is that it does not use air blowers, which require expensive electricity. This is a light blue sponge just after the start of the experiment. No microorganisms have grown yet. The sponge has turned gray due to microbial growth 45 days after the start of the experiment. About the lifespan of sponges. In my experience, the sponge I used to solid waste filter of my fish farming tank was slightly crumbling after 3 years, but it still kept its original shape. So I guess the sponge can keep its shape for 5 years or more. Now, Did the sponge collapse and reshape itself? Or did it collapse because the microbes ate the sponge? Unfortunately, the developers had no way of knowing this. Place a plant that hangs down around the sponge. The microorganisms in the sponge use the oxygen produced by the plants through photosynthesis to reproduce. The drooping plants cover the sponge. The water from the sponge will be blocked by the plants and will not be dispersed. Facilities surrounded by plants give people a good impression. Features of the sky method. Effective use of oxygen produced by the photosynthetic action of plants. That's what I noticed. You may be able to use live moss instead of sponge. The photo shows a moss, sphagnum, with a high water absorption rate that grows in temperate climates. However, this moss may not grow in a subtropical climate. So I guess that Pilotrichaceae sp, which grows in the subtropical zone, might be useful. The sponge may collapse and cause microplastic damage. This is the reason why I noticed that they use moss. The developer has not conducted any experiments with moss. It would be great if wastewater treatment could be achieved using only natural materials without using plastics. Section 6. Water dripping from the sponge collects in the circulating water catch tank, TK4. Section 7. Anaerobic microorganisms live in the pumice tank, TK5. This is an enlarged photo of a pumice stone. Numerous small pores can be seen. Microorganisms seem to live in these pores. This is a pumice tank for small-scale experiments. This is a pumice stone that is used to purify the fish farming tank. You can see the gray microflora around the pumice. Tuff can be used if pumice is not available. This is not a hard stone for construction, but a soft porous tuff are better. Red volcanic rock is also a good substitute for pumice. This is used in Japan to treat wastewater from pig farms. Zeolite would also be a good substitute for pumice. However, it would be more expensive than tuff or red volcanic rock. Section 8. Microorganisms that do not like oxygen also live in the coconut fiber tank, TK6. These anaerobic microorganisms also multiply by eating dirt in the water. This is the microflora that formed around the coconut fiber during the small-scale experiment. This is a coconut fiber submerged in the Estero de San Miguel River in Metro Manila, Republic of the Philippines. The water in this river is dirty due to untreated domestic wastewater flowing into it. However, the water around the coconut fiber is clean and fish live in it. In other words, the coconut fibers has the effect of cleaning the water. This video was taken about 7 years after the installation of the coconut fiber. We can see from this that the coconut fiber lasts a long time. It may be difficult to obtain coconut fiber in temperate zones. So the alternative is to use reeds. Another alternative is dried moss. This is readily available as a gardening material. It is Sky Method's policy to use materials that can be purchased in a hardware store on the street. However, hydrophilic carbon fiber is an alternative to coconut fiber. It is a better microbial carrier than coconut fiber. The empirical report is provided by Department of Chemistry and Material, Gunma College of Technology, 580, Toraibacho, Maibashishi, Gunma 3718530, Core Japan. Pumice and coconut fiber are not submerged in water. The top surface of them is in contact with the air. However, the water surface is below the top of them. Note, I wrote microorganisms that do not like oxygen or anaerobic microorganisms. But I assume that facultative anaerobe is also active in the case of sky method. Section 9. Water that has passed through the coconut fiber and pumice collects in the treatment water tank, TK7. After this, most of the water goes into circulation, feedback, and the rest is discharged to the 11 treated/purified water tank. Section 10. The water in the left parts of treatment water tank, TK7, is feedback to the dripping water tank and the circulating water catch tank, TK4, by the circulation pump, Pu3. The feedback volume is about 5 times larger than that supplied by the feed pump, Pu2. The sludge that accumulates at the bottom of the tank, TK7, is feedback with the water. In addition, the overflow water from the treatment water tank, TK7, which contains effective microorganisms, is feedback to the sewage and drainage channels. So effective microorganisms will also multiply in the sewage and drainage channels. Features of the sky method. It is characterized by a large amount of treated water circulation, feedback of sludge, and feedback of treated water to the previous stage and sewage and drainage channels. This method generates less sludge than the activated sludge method. In other words, the cost of sludge treatment and disposal is reduced. Section 11. The purified water goes out to the discharge channel. The overflow water from the left side of TK7 flows into the right side. The sludge are precipitation in the right side of TK7. The overflow water flows out to the discharge channel the sludge has after precipitation. Pumps and their power consumption for a practical scale experimental facility with a processing capacity of 10 cubic meters per day. Feed pump, Pu1. This is a submersible pump that is submerged in sewage and drainage channels. It uses a vortex-type pump that is resistant to breakage even when sucking in solids. The required suction volume per minute is only 7.64 liters. However, such a small vortex pump is not available in the market. So we chose a pump with a power consumption of 0.37 kilowatt. Float switch is used to operate this pump intermittently. Secondary feed pump, Pu2, and circulation pump, Pu3, pumps for ornamental fish tanks are used for these. The reason for this is 1. This is because these pumps are capable of continuous operation. 2. Sludge and small foreign matter can be sucked up along with water. 3. Easily disassembled for maintenance. The developer used these pumps in a small-scale experiment for 6 months without failure. Shows the pump rating and required power consumption. The developers would like to thank the dozen or so people who have contributed to the sky method. Unfortunately, the developer estimates that I will not be able to complete the development of this method. So I hope that many people around the world will be interested in this method. The developer has experience in the design, fabrication and operation of pure water production plants for semiconductor factories and wastewater treatment plants. They are facilities that use steel, concrete, and large amounts of electricity to violently operate in a noisy and bustle environment, damaging the natural environment and dehumanizing facility. So at the flip side, a quiet way to spend less money. It's always somewhere. That's why I want someone other than me to re-experiment with a different perspective. with a different consciousness. What we need now is the collective wisdom of many people. The developers do not expect that the Sky method can deal with all wastewater treatment problems. The Sky method should be a flint for them. Thank you for taking the time to watch this video. Please watch the Sky Method Chapter 3 Parts 3 Progress Record of Sky Method Development if you haven't seen it yet. Its web address is in the description field.